everyone. Welcome to this presentation for the ARRL Learning Network, an initiative of ARRL, the National Association for Amateur Radio. There are so many ways radio amateurs can discover new ways to enjoy our pursuit of radio technology and communications. And this webinar series is our way to help connect experienced members with all members so we can share knowledge and experience. So thank you all for being here today. I'm Chris Bickle, K1BIC. I'm the Lifelong Learning Manager at ARRL. I'm a member of the Learning Network team and today's webinar moderator. Today's presentation is Finding and Fixing RFI and is being presented by Paul Cianciolo, W1VLF from the ARRL Lab. And today's presentation is being sponsored by ICOM. The session will be recorded and will be available on our Learning Network page approximately 24 hours after the session ends. During the presentation, we encourage you to submit questions using the question box found on the right side. And at the end of the session, we'll try to get to as many questions as we can during the Q&A period. So before I turn this over to Paul, we have a couple quick questions for you to answer that you'll see on the screen. You should see the questions on the screen and you can go ahead and mark your answers. We'll allow a couple moments for those responses to come in. Just another few moments. All right, we are going to close the first question. And we have about 40% who are here looking for guidance for an existing RFI issue, and the other 60% are just here to learn about RFI in general. We do have one more question for you. Here is the second question. Just give that one more moment and then we'll close it out. And we have a few of you who've used the TIS recently, a few who've used it but not recently, and most of you say that it's the Technical Information Service. Is nice to know that it's an offering from ARRL. So that's all for the intro. Paul, it's all yours.
Okay, Chris, thank you. And I'd like to welcome everybody. Thank you for attending. According to that last poll, it looks like there are 40% of you that have a specific RFI problem and 60% don't have any RFI problems. And to that 60%, I'd like to say, do you have a couple of acres you wouldn't mind selling me? Because it's, trying to find a QTH that's that quiet is really important. Anyway, here's my email address. This is going to be basically an overview of the bulk of the RFI issues that we take care of here at the ARRL. It's not going to really specify very technical fixes for any one of these, but generally these are the categories, and if there is questions, you can always email me at that email address and we can talk about it specifically, or you can give Chris those questions and we'll go from there. So what are we going to be talking about today is what really is RFI, radio frequency interference. You know, back 50 years ago, what were the sources of radio frequency interference? Maybe they were power line noise, maybe it was a welding shop up the road, maybe you had television interference from your neighbor, or your neighbor had television interference from you. But there's a lot more devices out there right now. What are the major causes of RFI? We'll talk about that. And how to identify some of these devices in your station and what you can do about it in order to mitigate this, eliminate it. We'll go into all those things, but we're not going to spend a real lot of time. Again, if you have specific questions, we can always be reached through email. So what is the actual classic definition of RFI? And it's an unwanted interaction between two systems. And if you think about this, it says any other definition carries an implication of fault or blame. Now, RFI, you know, if you're getting on your favorite band and there's a weak signal in there that you've never worked before and you can't operate, I mean, it becomes very emotional. We have to take emotions out of RFI. And you'll see why as we go forward in this presentation, because that interface between yourself and the existing or the generator of the RFI, that first impression is of absolute importance. And we'll talk more about that as we move along. So what's this RFI program anyway? The RFI database started in 2002 by Ed Hare, 19 years ago. And I think Ed's in the audience. He could pipe in if he wants to add anything here. But we have over 5,500 individual cases that have been documented in the database. These are cases, you know, with multiple telephone calls, multiple emails, multiple consultations, and they're located in the database. I routinely save all the pictures, the photographs, the screenshots, sound files, so that we can look at those later. Those are really important. And then countless other phone calls that don't really make it to the status of being put into the database. I have this problem. Oh yeah, that's right. We fixed it. Okay, great. I'm glad, you know, pass that information along to your friends. And another thing is there's 3 editions of the RFI handbook out there. The most current one is number 3, and that's a really good resource to find information on, you know, locating and helping out, you know, locating what are the fixes that you can do, you know, how to eliminate RFI. So I always like to put this line in here. It says, let's thank the major players. The major players here, because if it wasn't for this, I wouldn't be here. I would be out of a job and I'd probably be on the beach somewhere working on my tan, which you can probably tell is not too good right now. But this is a list of 9. It's not a comprehensive list, except for the first 90% here of cases. In the world we live in right now, power line noise, LED lighting, and solar power are the big 3. The GMC, the Ford, and Chrysler of the noise world, if you will. Switch mode power supplies make noises. To some extent, there's some plasma TVs, but computers, routers, modems, in an effort to make things very efficient, heating, ventilation, and air conditioning appliances, they're all using electronically commutated motors, and those have solid state controllers, so there's noise affected there. New laws went into effect about building homes with arc fault interrupters. That's often a source where the amateur keys his transmitter and breaks 4 breakers at the same time for unknown reasons. Dog fences are some people have problems with these, but they're not really a major issue. But you can see, and then the unknowns, right? Some sources are never discovered. Some sources come and then they're there for a few days and they leave, and you have no idea how they started, why they were on for 2 days and disappeared. But the bulk, the lion's share, are these 3 right up here. And I like to say, hold the phone or the microphone. You have a choice, or not a choice, but the noise is one of 2 places. It's in your house or it's outside your house. And 50% of the time, and I wouldn't have believed this until I really was immersed in this project, that 50% of the time, that noise source is in your own home. And so instead of trying to DF this to a neighbor that's 6 houses down that you think might be the source of your RFI, it's always best to turn off the main breaker, power your radio by battery. If the noise goes away, you're in a great spot, because now you have ultimate control over, you know, whether this device is on or off if it's in your own home. Once you have to go into the field and interface with another person, it gets orders of magnitude more difficult. Oops, I guess I could go in the right direction, huh? And so a lot of times folks will send me a video, right? Everybody's got, seems like, an SDR with a waterfall, and they've got the ability to record, or they'll send camera video and they'll say, hey, what is this? You know, this is happening at my house. You know, can you identify this? And except for the first three, the power line, solar power, and grow lights, there's millions of articles out there that can generate RFI. Zach, one of the staff members here, did a search on Walmart and found, I think, something on the order of 10,000 devices, electronic devices, sold by Walmart, one vendor, that have the potential to make RF noise. So even if I could tell you, well, Phil, it's the Philips A27.X light bulb, would you want to go around to every one of your neighbors and ask them if they have that? And would they even know if they had that? So we're trying to be as unobtrusive as possible with our interfacing with the neighbor. It's tough enough to just go to that one person. And so we try to get it down to where before what. Okay, and once we know the where, the what is a lot easier. And another quick comment here is that the technical aspect of this, how do we fix this problem? Well, there's filtering, there's common mode filtering, there's EMSafe filters, there's physical distance, there's all these different ways to fix this technically. The issue is finding out where it is and interfacing with your neighbor and getting the cooperation. So this is a really important, where is it before what is it? And the diplomacy is needed. Now, think about this for a second. This is real. This is from actual cases. An amateur radio operator has an RFI problem. Oh, it's killing me on 75 meters or 160 or 40 or wherever it is. And he does the work, right? He DFs it down to a particular home in his area. And now he walks up and he talks to the person in that home and says, you know, he could say, by the way, I'm trying to find a problem here. Can you help me out? Or he could go up there and say, hey, there's something in your house that's not within FCC rules. Now, okay, so that's his perspective, and it's a little bit emotional. The operator, the neighbor, thinks, how could this be? My TV works really well. My internet's working. My Wi-Fi is working. My cell phone works. I listen to FM radio. I don't have any problems with anything. Must be your fault, whatever you're doing over there. So a lot of times the neighbors don't have a real concept. So the approach is absolutely paramount. And even knowing these technical solutions, if you can't make that contact with the neighbor and apply these, it's not going to do you any good. And that's what I strive to not happen. When someone tells me that they've done the DFing work, oh great, we've done all the technical work, how do I approach that person? You know, and we'll talk a little bit more about that later. RFI, and this is kind of more of the same, right? RFI problems involve people. Now, the operator of the device, the operator and the victim, the amateur radio being the victim in this case, he's operating a device that, well, I looked at it and it says FCC approved. I paid good money for it. I don't have any problems on my end. So a lot of times they need a kind of a tender, sort of cordial, very much you asking for help with a problem that you're having, so that the neighbor is like, oh, wow, I'm contributing to helping you find the cause of this problem. That's probably one of the better ways to go about it. You know your neighbors. You have to make that decision on how you do that. But absolutely, a lot of cases that I've dealt with, people go over there and go, well, you know, by Part 15 here, you can't be doing this in the FCC, and I just wrote a letter to my congressman. That's not the way to get this thing mutually fixed, repaired. And this is what kind of happens. You know, here's the ham radio operator with the handheld, and the neighbor's got his television antenna over here, and it looks like the tower on this house, and there's interference back and forth. This is what you don't want to have happen. Even if it, now let me just say one thing here. Somebody operating a device in their house is, by law, by FCC law, if it's a Part 15 device, responsible for the operation. If it causes harmful interference, they are the operator, they must shut it down. Now, as the amateur operator, you have that on your side, but is that the first card that you play? If maybe you want to end up like the two folks on this picture, but that's not the suggestion that I go with. And so the FCC defines harmful. What is harmful interference? I mean, if I'm on 144/200 working a guy 500 miles away on 2-meter single sideband, and there's an S1 signal in there from my neighbor's whatever, television set or whatever device it is they're having, the FCC won't consider that harmful interference. It's harmful to me because I can't make that contact because I need that grid square. Or if if 24 opens up and there's a really weak signal there and your neighbor's pool pump is covering it up, that's not harmful interference because we have all these other bands. It may be in your mind and in your heart, but the FCC says it has to be seriously degrades, obstructs, or repeatedly interrupts radio communication service, amateur radio. But the FCC has also given us multiple bands and frequencies, and we have the agility. So they're not going to consider a single carrier, or very unlikely to consider a single carrier or a single noise source on a single band that will be open in 3 years as a real problem. In the event diplomacy doesn't work, the ARRL has an agreement with the FCC. Excuse me. The FCC has said, look, we don't have the manpower. If you guys at the ARRL work with the ham, work and do the due diligence, discuss proper DFing techniques, precisely locate the noise, notify the neighbor, the utility, or the business, and work on a local level. And that's what I try to do. I try to get the amateurs and the neighbors to work on a local level because I could get involved, and you'll see here in the next page how. But I'm 2,000 miles away from a lot of folks. We're here in Connecticut and 3,000 miles away from people on the West Coast and 1,500 from Florida, and I don't know your neighbor, and I haven't lived next to them for 25 years. So working this out on a local level and making that initial presentation to the owner of the operating device is, again, I keep stressing this, I keep saying it over and over, but it's really, really important. If you go in there and you find a device and you say, oh, it's this power supply, well, there's fixes, there's technical things we could talk about it. There's no question that we can rectify the problem or buy another piece of equipment to fix the problem. But it's just getting that neighborhood, that back and forth between your neighbor on a cordial level. So let's talk about some of the real big power line noise. Again, this is just kind of a slide that shows what we're going to go into here now. Power line noise, LED lighting, grow lights, and then we'll just touch on these. So the first one is power line noise. And power line noise is almost akin to lightning. If you think about it, you listen to your AM radio, you hear lightning noise. You listen to 75 meters, you hear lightning noise. You listen to 20, you can hear it, all the way up to 2 meters. So it's extremely broadband, and so is power line arcing because it's the nature of an arc. It's full of harmonic energy, so it's going to diminish as you get higher in frequency, but it's still going to be there. And that's really a plus when we want to go looking for it. So if you have a 20 over S9 noise level at your house that's determined to be power line noise, that's not really the frequency at, say, 160. You want to move up to where the noise is much more diminished, a place where you can use antenna systems that have good directionality and do some vectoring to find out where those sources are. Typically, not always, but typically harmonic energy caused by an arc has 120 hertz intervals. And that's something I think in the, well, I guess I don't have that slide in here anymore. But this is another kind of an old wives' tale. Don't bang on the poles. There was a case, and Ed would back me up with this, where there was an insulator going bad and the wire actually broke off after being hit by a sledgehammer on the pole, and the amateur is no longer making transmissions, let's say. So let's move on a little bit here. The other big one is grow lights. Okay, sometimes we call this orchids, but to be totally honest, it's most of the time marijuana grow lights. And the problem with those grow lights is the electronic ballasts. These devices are typically imported from foreign countries, Asian countries, where either the design never included any EMC filtering, or it was taken out at some point. But these lights run at the 1,000-watt level. So if you have 3 or 4 of these lights in your house running these on, running for the production of either medical, recreational, or whatever your state happens to allow at this time, they can make an awful lot of noise. How do we fix this? There are filters. This is a known problem. There are filters that can be purchased that will fix this problem, and have in many cases. The other thing is California. And California is kind of big when it comes to RFI because they've got a couple of state mandates. One is this new LED lighting or efficient lighting, whereas in the old days, just a standard incandescent bulb made almost no noise that an amateur could hear. Switching power supplies drive every LED light that's out there. And the ability to purchase stuff on eBay or Amazon that's non-conforming with Part 15, it's very difficult to imagine the FCC or Customs looking at every device to make sure it passes muster. And even if they did, I could order right now from any country in the world and have it here in 3 days, a light bulb that's in non-compliance with Part 15. So this is a very different, a real big problem. Although some of the stuff seems to be getting a little bit better, but there are still a lot of inexpensive. I mean, if you were selling light bulbs and the manufacturer or the seller of the bulb said to the manufacturer, hey, can you make these 10 cents cheaper? First thing that's going to go is the EMC filtering, because it won't affect the quality of the light. It'll just make lots of noise. And photovoltaic, solar power or photovoltaic systems. Again, California has a mandate that says every new home must have solar power, unless there's a very compelling reason for not having it. In other words, your house is in the middle of the woods and you wouldn't be able to actually have any sunlight impinge on the solar panels. And of these solar power systems, and there are many different manufacturers, I'll just name a couple of them. One of them is, there's a company called SolarEdge, Delta, Enphase, Generac, Pika. It goes on and on. They all have different architectures. They all react differently when they're next to an amateur radio operator's home. But on one of the bigger offenders, there's a big clue, which you'll see 200 kilohertz carriers, a carrier every 200 kilohertz. How do I know? Is it on 24 hours? Yes, it's on 24 hours. Well, then more than likely it's not solar panel system. But the solar panels use the actual wiring of the system to transmit the energy. It's an unintended side effect of switching power supplies that are designed as what's referred to as optimizers, to try to extract the most power from the panel constantly under different lighting and temperature conditions. There's a great article in QST, Can Amateur Radio and Solar Power Coexist? And they can. Tony Brock Fisher wrote this article. You might want to go back and look at that. It's available. And he talks about all the different places where solar power can make noise and how can each one of those specific mechanisms be thwarted. And he put a lot of money into doing that. And now some of the things that we do with solar providers, I speak on the phone with the CEO of a couple of companies and technicians from other companies, and we're working towards getting fixes so that systems don't have to be retrofitted, but can be designed properly and wired properly. Again, I'm kind of going over this stuff really quick because we have a time constraint here. But later on, if you're, if you have a specific question, Chris is going to take questions, but he's also going to, pass on some of these, or you can ask me a question via email directly. I realize I'm not getting into a lot of detail here. Switch mode power supplies is another big offender. Your cell phone charger. Okay, so I'm in my office. I see a computer here that has at least 3 switch mode power supplies in it. Each one of the monitors has another one. There's 2, so that's 5. I have 6 LED light bulbs here in my office. That's another 6, so that's 11, and my office is just big enough to get me through the door here. So imagine what you have in your house. Every phone charger, every device has a switch mode power supply in it nowadays because transformers are inefficient. So in order to get to make things as efficient as possible, as energy efficient as possible, we have gone to these switching supplies, and there's nothing wrong with that if you indeed do the real filtering and EMC design ahead of time. Okay, so these are a problem. And here we go again, electronically commutated motors. I mean, in the old furnaces that had an induction motor, there wasn't any real noise. But the HVAC furnaces, air conditioners, washing machines are all striving to be motor energy efficient. Dryers, fans, speed controls, water pumps, heat pumps, all these things are trying to be as efficient as possible. And that means that they need an electronic controller. That means that they need several phases of energy developed, and it's usually developed using either triangle or square waves. And whenever you hear the word square wave, you got to think of harmonics. And if they're not suppressed properly, these things can be really big sources of noise. Again, all of these things add into the last 10% of the major contributors. So one of the ways that you can get rid of noise is using what's called a common mode choke. Now, this is an old set-top box. Looks like a Gerald set-top box from cable box from back when I was in the cable industry. So that was a long time ago. But if you see you have a coax cable coming in, another coax cable going off to the television set, and the power cable, and there's maybe even a telephone cable coming in. So let's just say that this device generates a lot of noise. Well, the device itself can generate all the noise it wants, but unless you allow it to come out this cable and radiate on top of, or conduct out this cable and let it radiate out to people in the neighborhood, that noise is not going to be a problem. The same way here, the same way here. And the other issue is if an amateur radio operator is transmitting, this cable running all the way out to the pole is picking up a lot of noise, and this choke acts as it has what's called choking impedance. It chokes off any RF that's coming on the outside of this cable that's either trying to get into your box or coming out of the box trying to get onto the power line or the cable line. And once it does, face it, we have a pretty good antenna system out there. Here's some other filters, and there's a few things to watch out for here. This filter, this is one of the 3-phase motor filters, so you'll see the three different wires here. And you'll notice they all go through this core. They don't go through once. They don't even go through twice. They go through 6 or 8 times to be an effective filter. And we'll talk a little bit about common mode chokes and free lunch here in a second. Inline filters, these a lot of times are built directly into the piece of equipment, and they allow AC to come into the equipment and all the RF noise to get chopped off right at this point here. This is essentially a low pass filter. And here's what a lot of people, these are really convenient. They're snap-on cores. But as you'll see here, unless you know what material this core is made out of, and I could show you 5 cores, or you could show me 5 cores and say, please, Mr. RFI guy, tell me what material these cores are made out of. And by looking at them, they're all black, I can't tell you. So let's see if you're going to spend your dollar for ferrite material to build choking cores. What we want to do is maximize the choking impedance. Again, that's to choke off RF noise coming out of a set-top box or any device, and it's also there to choke RF going into the box that would disturb the operation of the box. 1 second, please. Let me just grab a quick, sorry about this. So a lot of times folks will say, geez, I tried ferrites, didn't do a damn bit of good, okay? So, well, what band were you operating at? Well, I have a horrible noise at 160 meters. So let's take a look at this, right? Let's call it 2 megahertz. So at 2 megahertz, this is number 75 material. And again, 31, 46, 43, number 61, all these materials, including 75, look identical. They are just round discs, they're black, and they don't typically come marked. All my cores at home and here, I mark with the materials so that I know I have the correct one. So if someone said, I'm having a real big problem on 160 with common mode noise, well, let's see. Would I choose a number 61 core? Because for one turn at 2 megahertz, I might get 3 ohms or so, 5 ohms of choking impedance. A number 75 core would give me 150 ohms of choking impedance. More is better. But then suppose you were on 20 meters or 15 up here at say 20 megahertz. This core is no longer that effective. Or suppose you were at, let's say, 30 or 40 megahertz. Look how bad this core performs. That's why this number 31 is a fairly effective core. That's typically the one, if people are interested in the HF bands, unless it's specifically 160 or maybe even 80, I will say you need number 75 material to provide as much choking impedance as possible. So I told you were going to get a free lunch here. This is something for nothing. Now, most people have you believe you never get something for nothing, but that's not, in the case of ferrite cores, that's not true. So let's look at these cores. If we go back, here's the number 61 material, right? The blue line. Here's the number 75 material. And I'm going to use 2 megahertz. So if on a given core, you pass 1 turn through that core at 2 megahertz, you get 10 big ohms of choking impedance. Not really much to speak of. If you did that with the number 75 core, you would see you'd get 150 or 160 ohms of choking impedance. Now, if you pass 2 turns, this is where the something for nothing comes in. 2 turns, because it's the square of the turns ratio, instead of 10 ohms, you'll get 40. Instead of 150, you'll get 600 ohms. And when we're putting, cores in series, we want to choke off as much of this RF as possible and as much of the RF that's coming out of the box as possible. And if you went to 4 turns, you would go from 10 to 160 ohms or from 150 to 3,600 ohms, again at 2 megahertz. This chart would change if we were talking about 14 megahertz or 21 or 24, or even 28 megahertz. These materials would change. You would pick the core. So if someone says to me, well, I tried ferrites and it didn't make any difference. And the next question is, well, what core did you use? I don't know, I got them off Amazon. And so we don't know what the, there's my phone going off. We don't know what the material is purely by looking at it. But if you're going to spend your dollars on cores and your main concern is 160 meters, you're probably not going to buy these cores right here, which don't provide much choking impedance. So that's where you get your something for nothing. My mother always told me you don't get something for nothing, and God rest her soul, but I'd just like to tell her this if possible. if we go back here, this is the inline EMI filter. Okay, what this is supposed to do, if we look at this, we can say, capacitor, inductor, capacitor, inductor, capacitor. Geez, it looks like a pi network. It also looks like a low pass filter. So the 60 cycles that you want to drive your device, whatever this device is, passes through unabated. But the 100 kilohertz, 200, 400, 800 megahertz gets shunted to ground, high impedance, shunted to ground, and that's from a differential perspective. Common mode noise, there's two types of noise. Common mode, which means it's the same on both of these. So putting a capacitor here wouldn't do anything for you, but it would for differential. Common mode, you have to take it from both sides and shunt it off to either ground or a return path back to the noise source here. So that's kind of what's in there. Now, here's the deal though. Once it gets to here, once it passes through this filter, whatever's left hits the power line or the cable TV line or the phone line or your coax, whatever, and now it's out on the antenna. You don't have much hope of fixing it at that point. So these devices are imperative to have them built in, or that's one of the methods that you can use. And the other thing is, if there's noise out here on the power line, it also keeps it from getting into your receiver. So what tools do we have for locating RFI? Well, the first thing is the 50% finding, right? We want to make sure that we shut off the main breaker. So if the problem's in your house, we don't have to go outside. We can just work internally. A simple shortwave radio or an AM broadcast radio, if the noise is apparent on that receiver, that makes a great tool because it's got a directional antenna in it. One of the best that I like to use is an SDR radio because you can see the waterfall, you can see the video signature, the amplitude, the spacing, all the characteristics of that, and you can move to the outside after you've tried it on your antenna inside the house. You can take that with your portable loop outside and locate it, the noise, with a very good visual signature of that. The loops for far field and near field location, just small 2-foot near field loops. If folks want to know about those, we can talk about those online or via the phone. Please don't bang on the poles. There is a case where an amateur radio operator did. The insulator went bad and the line came down, and he's no longer with us. Ultrasonic dish is another great tool, but it works really for power line noises only, and you have to be very close to the pole. So what do you do if you can't eliminate the RFI? Well, you can use a separate remote receiver, a receive antenna located, in my case, all my antennas are located about 300 feet out in the woods in my backyard for receive. That keeps them away from physical noise sources. I use common mode chokes on all the feed lines so that no noise that's in my house propagates out to the antennas out in the woods where it's quiet. Small loops antennas, there's plenty of those on the market now, and by small I mean 2 or 3 feet in diameter. Those things have very nice directional nulls. If the problem is coming to you in the same, or excuse me, perpendicular and at 0 elevation, you can use those loops to null out a single source of noise quite effectively. If you have more land to deal with, you can use K9s, beverages, or excuse me, K9AYs and beverages. And the other, pretty powerful tool here, right down here, is the TimeWave ANC. I know MFJ makes a device, and so do the folks at DX Engineering have one, which is noise cancellation using a separate antenna. But that requires a lot of adjustment. It can be extremely effective, but we can't really go into the scope of that here. So really, it's a three-step process. Identify the problem. And when I say that, I mean, that doesn't mean you know where it is. You know what it looks like, you know what it sounds like, and you have a positive ID on it. Then you can locate it. then you can interface with the operator of the device. And of course, that operator might be you, which is the best possible case, because then you can work on the problem yourself. Consumer devices are common forms of RFI, both out of and into. I don't know, just about any device with a switching power supply in it can make noise. That's a battery charger, that's a cell phone charger. And we also, as amateurs, can get into those. But most of those fall under the Part 15 rules, which means those devices must not be used in cases where they cause harmful interference to a licensed radio service. And they also must accept any interference that they receive from a harmful interference from a licensed radio service. And this is important. Under the FCC rules, the operator of the offending device is responsible for correcting that problem. So if you own the device in your house, you are the one that's responsible for fixing that. What are the big threats coming up in the future? And here's one that I see. Besides multiple, thousands and thousands of new devices coming online, the real big one is wireless power. And we're doing, my boss Ed is working with a lot of the manufacturers right now to minimize this problem. They're using levels from 10 to 50 kilowatts of inductive charging and all the different problems that could be associated with that. Ed is working on that. I see continued growth in the residential solar systems, and I'm glad to see that, but along with that is going to come a slew of RFI problems. And then more states are legalizing the home growing of, I guess you could say, medicinal herbs or marijuana. And as that happens, more people are going to be growing their own, so to speak. And in which is the third big problem for me, which is the RFI emitted by the ballasts and the lamps in that situation.
Let's get to some of our questions. Okay, first questions. Even if there's no RFI, is it best practice to put ferrite beads on all power leads close to the radio? And is one enough? Are there any certain types that you should use?
Typically, it depends on what you're talking about for frequencies of interest. If you go back to this slide and you're interested in, for instance, the lower frequencies, then you would use a number 75. If you're interested in 10, 15, 20, you would use a number 31 core. RFI can be a little ambiguous, because there may be noises that you cannot hear and identify, just white noise from microprocessors. If you at all think that you have a problem, choking off the noise at all the possible sources is definitely recommended.
Next, do ferrites work for differential mode noise, work better for reducing RFI from LED lighting, or work better for the common mode windings?
If I had a definite differential noise problem, I would be going with this filter here, because look at the multiple stages. This is essentially a low pass filter. And if you can insert this into the line, this is much more effective than 5 turns on a single ferrite core. This goes on the AC side of the line, and that's predominantly the conducted emissions antenna. However, if you're talking about 2 meters, then ferrite cores may be your only way out on a common mode problem on the lamp side of the power supply. So that's kind of that would be more of a one-on-one kind of a question, Chris.
Okay. Is it permissible to replace AFCI circuit breakers with standard circuit breakers?
That's a zoning question. I can't answer that. Yes, AFCI breakers. In fact, a company called Eaton had big problems with them. Their algorithm to tell whether or not an arc was occurring was also saying every time an amateur radio operator transmitted, that's an arc, and it would shut off all the ones in the house. If you have Eaton breakers, there is, as of, I forget the year, 2015 maybe a little before that, there was a definite cutoff as to when the new algorithm and the new ham certified, RF certified breakers were out there. I personally would not do that. I would not change those because I think they're in there for a reason, and I think they're in there for building codes. Yes, they're a pain, but there may be other ways to rectify that. You'd have to consult your building codes.
Okay, we're just about out of time. So what we're going to do, since there's quite a few more questions, is we're going to let anybody who needs to drop off for time reasons drop off, and then we'll continue with the Q&A, and they'll be able to access it via the recording. We'll also forward any unanswered questions to our technical information service to be answered individually. So with that, next question is, if a neighbor will not comply, will the FCC be able to approach the individual and cause of the problem and force the neighbor to comply?
If it's truly a case of harmful interference, for instance, you have a 20/9 or an S9 noise level on all the bands, that the FCC would consider to be harmful interference. But the first step would be that if you did make a complaint to the FCC, they would send it to me, and then I would ask you, geez, I did, Chris, did you do all the DFing? Yes. And I've also approached my neighbor and they told me to go pound sand. Then at that point, if I thought it was harmful interference, and the FCC is allowing me to make that judgment, not judgment, but to consider it, whether it falls into that category, I would write that neighbor a letter and remind them of their responsibilities of running a device, Part 15 type device in a home. And if that did, and that takes 60 days after I send it. And in that letter, the amateur would be mentioned, the pertinent regulations would be mentioned, the ARRL would be there to to help any technical questions, that sort of thing. And if that didn't work out, then after 60 days, I would forward it to the FCC and they would send them a letter and hope for a response. And at that point, they put, it's up to the FCC as to how they view that, whether or not their resources would be spent wisely going out there. Most times when the FCC sends a letter to someone, it's not just coming from the ARRL, it's coming from a government agency, and that gets people to work together.
Next question is, what does MPPT stand for?
It stands for Maximum Power Point Transfer. If you have a solar panel on your roof, and let's just say we have one solar panel for this first example. If you have one solar panel on your roof, the maximum output that panel makes is a function of a whole bunch of things. The angle of the light that's hitting it, the intensity of the light that's hitting it, the temperature of the light that's hitting it, and those things all play together constantly over the course of a day. The maximum power point transfer, what that does is it's constantly interrogating the panel. Well, that's not a good way. It's constantly trying to pull the maximum power. And a quick way to think about this is, if you put a short across a solar panel, you get maximum amps, but what's the voltage? 0. So there's no power. If you leave a solar panel wide open, you'll get maximum voltage, but no current. So what's the power? 0. There's some point in that on a sliding slope that's based on, again, temperature, age of the panel, impinging light, and other factors that this optimizer or MPPT device, maximum power point transfer, is constantly trying to achieve the most out of that panel. Typically over the life of a panel, you might see 7 to 15% difference by using those. But now you have a piece of switching electronics on the roof, which can cause RFI issues.
Next, is there a slide or another resource that's not in the slides that shows the type of RFI and the source and the distance in feet that the source would be a nuisance, some type of reference that may help troubleshooting?
Yes and no. There are, In general, the more power that something is using, the more potential there is for it to cause widespread interference. Case in point would be a grow light. But you can't really, well, I'll give you a couple of instances. I have one individual I'm working with where he has 9 grow lights, and that's an S9, 1,500 feet away from where he's operating on 75 meters. And I mean, there's so many factors in there. How good is the antenna? Well, what does that mean? Well, that means how good is the power line at radiating at 3 megahertz or 7 or 21? And you know, what's the design of the ballast? How much was the filtering? Really not an easy question to answer, but in general, higher powered devices have higher, just like you would expect running a kilowatt, that there might be more second harmonic and third harmonic energy than if you were running just a single 100-watt transmitter. If you wanted to talk about a lot of the idiosyncrasies of that, you could send me an email and we could talk about it.
We'll go with a couple more questions here, Paul, before we wrap up.
Okay.
Next is, how effective is an MFJ noise nulling device for local interference?
Okay, this is a really good question, but as I used to listen to Joel Hallis, the doctor, and he would always say, it depends. It depends on a number of things. It depends on the distance to the source of the noise, whether it's coming from one location. I can tell you that I've used the MFJ 1056. Is that it? I don't remember the number. The ANC4 and also the DX Engineering device, all with great success. But the important thing is you need to have good quality noise. Now that sounds like, what the hell does that mean, good quality noise? You need to have a source of noise, the offending noise, and nothing but that noise, which means, let's say, for instance, in my case, my solar inverter makes a lot of noise. Can't operate 75 meters with that thing going. I could take another antenna, string it out in the backyard, and do the noise canceling thing, and I might get 20 dB of suppression. But I'm also adding in other noises that never were there in the first place. So quality noise is when you can separate the undesired one noise source, which happens to be my inverter, and I do that by using a near-field loop that's only 6 inches in diameter. So the chances of it picking up other sources are pretty bad, but when it's only a foot away from the inverter, it gives me high quality noise that I can invert, balance the level, and get a reliable 40 to 60 dB of attenuation. That was a long way around, wasn't it?
That's okay. We have another question. Is there anything that can be done about products from sellers like Amazon that sell devices that are not compliant and cause interference inside my home?
I think the question is about Amazon itself, and maybe Ed might want to chime in here. Are you still on the call, Ed? Maybe not. I suppose if we found, here's what I find. Battery chargers, Harbor Freight, Amazon. I muted you?
Thank you.
Oh, can you unmute Ed? Harbor Freight, Amazon, they all sell the same battery charger, has different names on the outside, all made by one manufacturer. If we knew who that manufacturer was, we might be able to get something done about that. But these things are ubiquitous. So yeah, that really pains me because they're available for such an insignificant amount of money, but they cause so much problem. And maybe Ed can chime in here. Ed, are you?
Yeah, I'm here now. Hopefully everybody's hearing me. But, we've been looking at some of these noisy devices, making actual measurements. And when we find devices that are operating significantly over the FCC limits, we have and can and do file interference complaints with the FCC. I know years back when we first looked at some grow lights, we found one model that was 58 dB over the FCC limits. Now, let me put that in layman's terms. One device making as much noise as 650,000 legal devices. And so we're identifying more of these. I found a battery charger being sold by Harbor Freight, measured 43 dB over the limits. We're expecting to be able to file complaints about that. And much to my shame, I found one in my own house, an eBay computer power supply running about 40 dB over the limits. So Ed Hare had an RFI problem. Fortunately, I'm going to be able to keep that a great secret.
Thank you, Ed. We have one final question here, Paul.
Sure.
If we locate the RFI source as a power line source, what do you recommend as a way to start the conversation with the power company? And are they obligated in any way to fix it?
Yes, you want to talk to the power company, but what I've seen happen, and as with any of these, it runs a huge gamut. Some power companies are out there a half hour later and they want to rectify this problem. Some power companies see RF noise as a potential future failure in the power line system, in the power system. Some companies just will consistently, say yes, sir, we have your problem, and then never do anything about it. What I usually do in that case is, after one or two attempts of talking to people at the customer service level, is to A, make sure that you get a ticket number so that you're in their system, and B, try to get further up the line to a supervisor. If you can't get up the line to a supervisor, I'll go online, or I have gone online. You can go online and find somebody in the that's even farther up the food chain, somebody in their management organization that doesn't really want to hear from you because you're talking to him about a very low-level problem. Someone who has the power to get these things done, force it out there. Two things that are happening here. One is you have a really small power company in some cases. In fact, it might be a co-op with 5 other companies that doesn't have the expertise to fix it. They don't really know what to do with it. They don't have the equipment to fix it, and they don't have the skilled people on hand, or they have to wait for the equipment to come from one of the other co-ops because it's in use. But the squeaky wheel gets the oil. And you have to move yourself past that defensive line. That's, past the first step of, a lot of customer service representatives don't know what an RFI problem is. They don't deal with that every day. They're really good at getting your power system fixed, but noise, not so much. So yes, I would say start through the proper channels. After 2 times you call them and there's no satisfaction, or promises are made and they're not delivered on, then you go further up the chain to supervisors. If you can't get to supervisors, then you can go up, try to find somebody online in the management organization, or a business manager in that area. Last thing he or she really wants to do is to be bothered by some problem down below, and they'll make sure the resources get available. If that doesn't work, then the same goes for this RFI problem. We can write a letter, once you give us the information about who the CEO is or the local representative, and pass it up the line. It's they're trying to protect. After all, you think about it from their perspective. They may not know what this even means. And it runs the whole gamut. Like I said, some power companies are out there the same day. Some power companies keep pushing it off until you have to get a little firm.
All right, Paul, thank you for a great presentation and a lot of great answers. Do you happen to have a slide that shows how to contact the Technical Information Service?
You can just go to TI. I don't have that slide up here, or maybe I do. Here it is right here. You're right. You can use this, ARRL Technical Information Services.
Great, perfect. Thank you so much. You can also go to the website and type in Technical Information Services on the ARRL homepage. So thank you again, Paul, for your time. Thank you for everybody for joining us. Just a reminder to visit our Learning Network page for a schedule of upcoming webinars and recordings of past presentations. You'll receive an email today with a link to the recording, along with our link to the Technical Information Service. Our next session is HF Noise Mitigation, presented by ARRL Northwestern Division Director Mike Ritz, W7VO, on Tuesday, May 6th at 3:30 p.m. Eastern Time. You can find that on our Learning Network page. And we're also always looking for more presenters, so if you have an interest to share, there's a link to our call for presenters. So Paul, thanks again for your time. Any final words?
No, I think I just need a cough drop now, Chris. Other than
Great.
that, I'm fine.
Thank you so much.